Stars are born, they live, and then they die. But not all stars die the same way. Some go out with a whimper, others with a bang. The biggest, baddest stars in the universe, when they die, leave behind something truly bizarre: neutron stars. Imagine a star more massive than our sun, squeezed down to the size of a city. That's a neutron star. We're talking about matter packed together so tightly that a teaspoonful would weigh billions of tons. The gravity on a neutron star is so strong it can warp the fabric of space-time itself. How do these extreme objects form? When a massive star runs out of fuel, it can no longer support itself against its own gravity. The core collapses and the outer layers of the star explode outward in a brilliant supernova. What's left behind is a dense, spinning ball of neutrons, a neutron star. These stellar remnants are some of the most extreme environments in the universe, with crushing gravity, intense magnetic fields, and temperatures of millions of degrees. Space is vast, but it's not empty. Stars, planets, gas, and dust are scattered throughout the universe. And sometimes, two neutron stars, those ultra-dense remnants of dead stars, find themselves locked in a deadly embrace. Imagine two objects, each more massive than the sun, spiraling towards each other at incredible speeds. Their immense gravity distorts the very fabric of space and time around them. As they get closer, the dance gets faster and more furious. The energy released in these final moments is almost unimaginable. It's like a billion suns exploding all at once. This cataclysmic event is what we call a neutron star collision. These collisions are rare, but when they happen, they shake the very fabric of the universe. When neutron stars collide, they don't do it quietly. These cosmic crashes are among the most powerful explosions in the universe, releasing a blinding flash of energy known as a gamma-ray burst. Imagine the most powerful lighthouse you can, now make it a billion trillion times brighter. That's the energy we're talking about. These bursts of gamma rays, the highest energy form of light, travel across the universe at the speed of light. If a gamma ray burst were to happen close to Earth, don't worry, it's very unlikely. It could strip away our atmosphere and sterilize the planet. Luckily, most gamma ray bursts happen very far away, billions of light years from us. But they are still visible to our telescopes, appearing as brief flashes of light in the distant universe. Remember how we said that neutron stars warp space-time? Well, when they collide, they create ripples in this fabric, like waves spreading out from a stone dropped in a pond. These ripples are called gravitational waves. Albert Einstein predicted gravitational waves back in 1916, but it took us a century to finally detect them. In 2017, scientists using incredibly sensitive instruments felt the faint tremors from a neutron star collision billions of light years away. This discovery was a major triumph for science, confirming Einstein's theory and opening a new window into the universe. By studying gravitational waves, we can learn about some of the most extreme events in the cosmos, like black hole collisions and the Big Bang itself. Section 5. The Cosmic Alchemy of Neutron Star Collisions. Neutron star collisions are more than just explosions and fireworks. They are also cosmic furnaces, where heavy elements are forged in the fires of extreme conditions. You see, the universe at its birth was mostly hydrogen and helium, the lightest elements, but we know there are much heavier elements out there like the carbon in our bodies, the oxygen we breathe, and even the gold in our jewelry. So where did all this stuff come from? Sure, stars make some of it, but the really heavy stuff like gold and platinum, that's where neutron star collisions come in. The intense heat and pressure during these collisions act like a giant cosmic alchemy experiment, smashing atomic nuclei together and creating new, heavier elements. It's like the universe's ultimate recycling program, creating the building blocks of planets and even life itself. Section 6. Forged in fire, gold, platinum, and other treasures. Think about this. The gold in your wedding ring, the platinum in your necklace, they were all created billions of years ago in these cataclysmic explosions. The very atoms that make up your body were forged in the hearts of stars, or in the fiery collisions of neutron stars. It's a humbling thought, isn't it? We are all connected to the cosmos in a very real way. The atoms in our bodies are literally stardust, created in the fiery crucibles of long-dead stars. Next time you look at a piece of gold jewelry, take a moment to appreciate its cosmic origins. It's a tiny piece of a neutron star, a relic of a cosmic catastrophe that happened billions of years ago. Section 7. Windows to the Universe. Neutron stars as cosmic laboratories. Neutron stars are more than just fascinating objects, they are also incredibly valuable tools for scientists. Think of them as extreme physics laboratories in space, where we can study gravity, nuclear physics, and the nature of matter under conditions we could never replicate on Earth. By observing neutron stars, we can test our understanding of fundamental physics. We can measure their gravity, study their magnetic fields, and learn about the exotic states of matter that exist inside them. Neutron stars are like cosmic beacons, shining light on some of the most extreme and mysterious phenomena in the universe. Section 8. Mysteries and Marvels. Unraveling the Secrets of Neutron Stars. Despite all we've learned, neutron stars still hold many mysteries. We don't fully understand what goes on inside these extreme objects. What is the nature of matter at such incredible densities? What causes their powerful magnetic fields? And what happens when a neutron star collapses into a black hole? These are just some of the questions that keep astrophysicists up at night. Neutron stars are a constant source of fascination and wonder, pushing the boundaries of our knowledge and challenging our understanding of the universe. The study of neutron stars is a journey into the unknown, a quest to unravel the secrets of some of the most extreme and enigmatic objects in the cosmos. Section 9. Our Place in the Cosmos. Lessons from Neutron Star Collisions. The study of neutron stars and their collisions reminds us of the vastness and wonder of the universe. It also highlights our own place within this grand cosmic scheme. We are all made of stardust, forged in the hearts of stars and the fiery collisions of neutron stars. These events, as destructive as they are essential for creating the elements that make up our world and ourselves. They are a reminder that we are all connected to the cosmos, part of a vast and interconnected web of energy and matter. By studying the universe and its wonders, we gain a deeper appreciation for our own existence and the preciousness of our planet. So the next time you look up at the night sky, remember those distant flashing lights. They tell a story of cosmic drama, creation, and our own place in the universe.